Hello there, and welcome back for episode 2 of our Let's Play. From this point on, we pretty much have two choices. Either we could build a plane and do some flying around, or we could build a rocket that could either do a suborbital or even an orbital. However, I don't actually have any missions to do any suborbitals or orbitals really right now. But I do have a ton of missions for doing flight surveys. And we did just blow 75 grand upgrading the runway. So I'd really like to recoup those costs, and you can see these observational surveys, you get about 20,000 for doing them, so it's a really good way to make money because not only are you getting 20,000 per reading, but you're gonna be landing your plane, so you're gonna recover almost all of your craft cost. So you're essentially not spending money to get this money. Now, as far as these missions go, there's two different types. There's below and there's above. The below ones are a lot easier because it doesn't matter what altitude you're at, because you're not going to be flying above 16,000 with the beginner parts anyway. The above ones are a little trickier because to get up to 20,000 with just basically the parts we have available for planes right now is almost impossible. So what you have to actually do is build kind of a rocket slash plane hybrid, which is probably what I'm going to build here. However, I can only hold 4 missions right now, so we are going to make sure we're going to grab the 4 that are below. Below, and below. After I do these, this will be kind of the test flight of the plane. I'll probably come back and grab these 2 and try that out, just to kind of show you how you can do a leap up and grab the readings. And this is my 3rd attempt at recording this. I think I finally finished the crashing, or fixed the crashing problem. Turns out I accidentally left the old folder co-e folder in with the stock visual enhancement. So I think it was a conflict if it was trying to run 2 sets of clouds. So hopefully this time I can actually get through this without it crashing non-stop on me and ruining everything. So yeah, we're going to go ahead and build our plane here. So planes can be a real pain in the ass for starter players. It definitely took me quite a while to figure out how to actually get these things to fly and everything else, but I'm going to show you a few tricks along the way that'll definitely increase your odds of being able to get a craft off the ground early on. Now the idea behind this guy is it's going to be a hybrid, as I was saying. So it's going to have a rocket tank in the middle there, what we're going to use to jump up to high altitudes when we need. And then it's also going to have obviously all the normal plane stuff so that we can still fly around and do everything we need. We're also going to use canards on it. Not a huge fan of canards, but I'm trying to build this so that it's very stable and very easy to fly, so that if you were to mirror it or copy it, you can definitely should be able to fly it without too many problems. So yeah, we'll just wait for this. Once I have it all kind of pieced together, I'll explain all the different kind of things that are going on with the craft. Okay, so we've got the base of the craft here. Now the 2 most important things that you need to do with an airplane is, 1, you want to make sure this landing gear is just a little bit behind your center of mass. I just kind of slapped it on there so you can see our center of mass is right here on the craft, so we actually want to, I'm probably going to push this back a little bit. The reason being is your back landing gear is going to be your pivot point. So when we try to pitch up for takeoff, it's essentially going to pivot right on those wheels, so you want it just behind your center of mass so that it lifts it up. The other big thing that you want to obviously watch for is the center of mass relationship to the center of lift. Now, technically if I was to launch this right now the way it is, it would fly. However, it would be extremely, I call it snappy. Like the controls would be very oversensitive and it'd be really easy to snap the plane and stall out your wings. So the general rule of thumb with this your center of lift and your center of mass. You always want the center of lift to be behind the center of mass. If you go in front, you're going to have all kinds of problems. However, the closer it is to the actual dead center of the center of mass is how it'll get more maneuverable and more snappy, and your controls will get really hypersensitive. The farther away you get, so if it was way back here, your craft would be far more stable, but you'd have a really hard time maneuvering. You wouldn't have a lot of control authority at all. So the sweet spot is kind of right around, if this was your actual center of mass, I would prefer to have the center lift right around here, which I will show you how I can actually move that and fix that in a second. But those are the two big things, is you always want to make sure your landing gear is positioned behind your center of mass, and you always want to make sure your center of lift is behind your center of mass. The other thing, if you're running, I've put parachutes on here, I shouldn't actually need them, but if you are doing parachutes on a plane instead of trying to land it, you want to make sure those are also directly over top of your center of mass, so that when they pop, the plane comes down, stays relatively flat. So those are the two big things. If you just kind of adhere to those, you will have a lot better chances of getting a plane off the ground right off the bat. Some of the other tricks that you can do with planes, however, the one thing is obviously your rest angle. So if I put this plane out there right now, it's going to sit on the runway relatively flat, just like this. You can actually have it, if I was able to push the front wheel up and the back wheels down and give it a forward lean, what that'll do is it makes taking off more difficult, but it'll make landing a lot more easy, because the plane has a natural pitch down, so you'll have to overcome that to take off. But when you go to land, it'll want to hug the ground, so once you actually touch down, it'll really stick to the ground. The only kicker with that is you may overstress your wheels, because the extra downforce is going to put some extra stress on the wheels. The alternative is you could also have it rest this way on the runway, which is going to be obviously your reverse. So it'll be a lot easier to take off, but it's going to be a lot more difficult to land. So it'll naturally just kind of take off on its own because you have a pitch angle. However, when you try to land, it'll get really bouncy, because the plane keeps wanting to actually lift off again, just because of the natural pitch of the lean. So we're not going to do obviously either of those. We're just going to keep it flat, so that essentially I have control over everything. The other thing you want to watch is where your center of thrust is, which I don't actually have up right now. You can see the center of thrust is in line with the center of mass, which is good. That means that you're not going to create any torque. If I was to put these engines up, for instance, beside these fins, it would lift the center of thrust up here, and you would create a torque force. And the torque force is, if you draw a line between where your center of thrust is and where the center of mass is, that's the way it's going to want to torque. So if I was to put those up there, the craft would constantly be wanting to push the nose down. And I guess if you think of it as like a wrench, if you connect a wrench from the center of mass to your center of lift, center of thrust, as that center of thrust goes, it's going to try to torque that wrench across the center of mass. So if it's up here, it's going to want to push the nose down. If your center of thrust was down here, it would want to push the nose up. So best bet for starter planes obviously is you just want to, that's why I push these engines down into the wings, is you want to have that center of thrust directly in line with your center of mass, so you don't create any torque force on the plane, so that again we keep it all, the pilot's going to control everything, kind of like the stance on the runway. The other thing you can do is, I don't do it very often, but it's something you could play around with later on. You can actually, instead of having these wings directly on the side of the craft, you can push them up to the top. If you have them up on the top here, sticking out, it'll be a lot more stable, and vice versa. If you put them on the bottom of the craft, it'll give you a lot more maneuverability. I'm not going to do either of those right now though, but it is another tweak that you can do if you're finding you need more stability or more maneuverability. You could push these wings up and down depending on what you need. And the last big trick to planes that you can also do is what's called angle of incidence. That's essentially, if I was to take these wings here, and let's make sure C's on yet. If I was to tilt these, you can see it actually while it pulled the center lift back too. But you can see the center lift now is on an angle. So essentially what I've done is these wings now have a natural pitch to them. So they're going to naturally want to kind of pull the nose up without me having to use any control surfaces, which can be a good thing. It's certainly a way that you can get a lot better horizon locks when you're flying, that you don't have to be constantly pitching the plane to overcome the natural like kind of drop that it's eventually going to get. And so how angle of incidence kind of works, in this case it's kind of backwards, but if I was to, for instance, angle these guys, as the plane goes faster and gets to its ideal flying conditions, because these have a natural lean to them or a natural pitch to them, they're going to start generating more lift than what the wings back here will, and that's going to create an offset balance, and that's where you get what I'm talking about, where it'll pitch up. So because these are generating more lift than the wings, the plane's going to naturally start to actually kind of pitch up on its own until the air either becomes too thin or you end up, or your speed maxes out or whatever. I'm not going to really play around with that for this craft, but I might make a plane later that plays around with angle of incidence. Angle of incidence is a really good thing to learn for planes because you can actually do quite a bit with it to create a more stable flying plane. So yeah, that's the bulk of the different tricks you can do. There's actually a really good there's a guide on the forums that goes through basically what I was just talking about, all the different things that can happen with planes as you fly them, but pretty much everything is based around the center of mass and your center of lift and their positions, and there's different tricks you can do to adjust those and move those around. Not so much your center of mass, but your center of lift you can certainly move around. So what I was saying earlier is I want to actually pull this center of lift back a bit. So what I'm actually going to do is I'm going to tilt these wings slightly, and that should... Heck, quit being so snappy. Is there not a spot in between those two? Whatever, we'll put it there. So I've just given them a very, very small lean. In fact, you can almost not even tell, but they are technically leaning down a little bit. So what that did is it pushed our center of lift back a bit away from the center of mass. I don't feel comfortable having the center of lift right inside the center of mass like that, because it creates a very unstable craft, and it's really easy to snap it and stall your wings. So having it back here will give us a lot more safety in flying, and even if we go hard on the controls, it shouldn't cause it to snap it really bad on us and stall everything. And then the last thing we want to do is actually, I need to go and set all of the control systems here. So our tail fin here is only going to be for yaw, that's your left and right, so we're going to turn off pitch and roll. And then these front guys here, I'm actually going to turn off, obviously, yaw, but I'm also going to turn off roll, so all they'll do is pitch control. And these back ones here, we're going to turn off yaw, but I'll leave roll on, so when we do a roll maneuver, these two elevons will control the roll, where both the elevons and the front canards will control the pitch. The one other thing I'm also going to do is you can control how much authority these wings have. Right now they're at 100%. I'm going to drop this down to 10. And the reason for that is I find with canards, if you have these at control authority 100%, it's really easy to snap the plane and essentially spin out and do a flip, because having a control surface at the very front of your plane like that gives it a ton of maneuverability, but almost too much to the point where it's really easy to flip yourself out. So by lowering it down to 10%, we eliminate the risk of snapping it, but we still get a little bit of pitch control up here to help us with takeoff and maneuvers and stuff like that. Otherwise, I think we should be good to go. I have one of every experiment. I got a bag, goo, a barometer, and a thermometer. I put the barometer and thermometer here so that hopefully Jeb can actually get out and take readings from those. One thing I should have mentioned before in the science flooring video actually is thermometer is one of the few experiments that actually takes biomes into account even when you're flying. So you can actually get a reading from flying over the water, the shores, KSC, mountains, grass. Like you can take a whole bunch of different readings where if I was to take barometer readings from those same spots, I would just get flying low, flying low, flying low, flying low. Like it's not taking the biomes into account, it's just taking your elevation. So I do wish I could take more thermometers because we are going to cover a pretty significant area here that we could have got a bunch of thermometer readings. But unfortunately I'm already at the 30 part count and I can't obviously EVA him in flight to grab the experiment. So we do want to set our staging here. So we're going to have just the jet engines go. The only time we're going to turn on the rocket engine is if we need to make an altitude jump. And then if all hell breaks loose, we can always pull the parachutes if we need. And I think we're ready to take her out for her maiden voyage. We're going to call her the Grasshopper. So, let's take it out for a flight. So one thing you're going to notice, this thing's actually going to bounce on the runway. It's mainly because of the mass of the vehicle, but if you just turn on the brakes, it'll stop oscillating on you. It's actually got a bit of a lean to it too. Should probably fix that, or whatever. So the reason for that is by having 3 rocket tanks with us, we're kind of pushing the mass of this craft to max for these wheels. We'll be fine on takeoff, but for instance landing, you're definitely going to probably burn off these 3 rocket tanks before you try to land, because it's so heavy that you're going to overstress these wheels and they'll probably crumple if you try to land with these tanks full. So even if you don't use it to jump to an altitude, just pop it off at some point and just burn off the fuel before you come down for landing. It'll make things a lot easier for you and a lot safer. Otherwise, we should be good to go. So we're going to turn SAS on, we're going to hit max throttle, and then we're going to light up the engines with the brake on. The reason for that, you can see, is that you actually take a while to get up to their max thrust. So by holding off the plane as long as we can, we're essentially optimizing how much runway length we have. So once it starts kind of rolling on its own, you can just pop the brake back off. And that way you'll get your max speed in the distance you have on the runway here. Most planes will take off 70 plus. Anything past 100, you're probably going to buckle the wheels, so you want to kind of take off between the 70 and 100 with these stock parts. So once we hit 80, we're going to lift our nose, and you do want to be gentle on the takeoff because you don't want to slam this engine into the ground. And we are airborne. So we did something right. So I'm just going to kind of let it get some height here, and then we'll give it a bit of a maneuverability test. So how flying planes works is typically you don't want to be using your left and right. That's your rudder fin here. That's more just to keep the plane straight. You don't really actually use that much for controlling. You can see it actually wiggles the craft quite a bit. So how you actually take corners in planes is you want to roll to the direction you want to turn and then use your pitch. And you want to be kind of gentle with it, and you want to essentially kind of chase this velocity vector with your pitch as you go, and you'll start making your corner. As far as the speed, you do want to keep an eye on this, especially when you're doing turns. So if I was to do a really hard turn here, let's see if we can get it going here. You can see the speed starts to plummet. So we turn really fast, but we lose a ton of speed. You do want to be careful, because if this drops below 70 meters a second, you're going to start losing lift and you're going to start losing control on your craft. So just keep that in mind, that that's kind of how fast you can turn. Is if you start bleeding off a ton of speed, you're going to want to back off a bit on how quick you're turning. Otherwise, she looks like she flies pretty good though. I've had this thing will fly down to about 50-60 meters a second. At that point, the controls are going to start getting floppy and you're going to start losing some lift. But you can get down that low, and probably will be when you come in for a landing. But yeah, that's pretty much the basics on how to fly a plane. There's not a lot to it other than just do rolls to do corners and be wary of your speed. Make sure your speed stays up. This thing really wants to nose down on me. That's okay. That's where your angle of incidence actually comes into play, is if you have angle of incidence, you can actually get it so this velocity vector is more centered on where you're actually heading. But that's not a big deal. So what I'm going to do here is I'm actually going to go out and get those surveys, the 4 missions that we have. It's going to be pretty long and boring though, so I'll just kind of explain how to do it here. So what you want to do is you want to bring up your map, and you want to click on the first reading that you want to take and click Activate Navigation. What that'll do is it'll put a marker on your nav wheel here, and then essentially you want to just aim the craft at that marker and fly towards it. You don't need to worry about the elevation of it, as if you remember, the reading is technically to take an altitude below 16,000, so that marker is actually up in the air at 16,000, so we're going to fly underneath it. So what we're waiting for and watching for here is either it'll pop up in green on the screen here once we enter the zone. Otherwise, once this marker kind of starts pushing up to the top of the nav wheel, there's a pretty good chance you're inside the zone and you can take your reading. When it comes to taking the readings, you don't actually have to keep the report. So when you take your crew report, you can actually just hit reset experiment and you'll still get credit for that mission. So, because obviously we can only have 1 crew report at a time, but we need to take 4 different readings. So I'm just going to keep recycling the crew reports after I take the readings. So you'll see, essentially if you take the crew report, hit recycle, you'll see you still have credit for the reading and it won't be on the map anymore. So we're just going to go ahead and we're going to fly to these markers, which there we just entered one. So you can see if we hit crew report and reset experiment, and we still have credit for the mission, even though we've reset that. So we're just going to open our map again, set our next crew, and now I'm going to go and get those other 3. Alright, so after a failed landing, this time I came down much better. I highly recommend against trying to land at 80 meters a second. That did not end well. Now I didn't land a KSC because I actually want to get all the signs from the grasslands here, so I just kind of landed somewhat near KSC but still out in the grasslands. And we're going to go ahead and run all of our experiments out here because we shouldn't have anything from grasslands yet. And I also, well, I burned off the rocket fuel before I came down to land. And I also have I kept the one crew report, which was over the highlands. So I actually want to, we're going to EVA Jeb here. Have him do the take and store. We'll get an EVA report. I don't believe I can plant flags yet. You need to upgrade something for that. So we'll just get him back on board, and we'll take our final crew report, and we should be able to recover it. And we should get a whole bunch of money and a whole bunch of science. So you can see we got about 23 science, and we got about 110 schmolians. So we've recouped the amount of money we spent upgrading the runway. So now what I think I might do is we're going to grab one of these flights above. Oh, look at the amount of money you get for that sucker. Too bad they're all above. There's a whole whack of belows though, that would be really good money. And a bunch more, man, that's... You go do 6 readings and make a couple $100 grand. That might not be a horrible idea. I should also probably spend some science. Really kind of want to go do those 2 missions though. Anyway, I'm just gonna grab one of these above ones and we'll just launch the same plane here, and I'll show you how you can get one of those using that plane. Okay, so as you can see, the nav marker has moved up to about 30 degrees now, so we're getting pretty close. So what I'm going to want to do here now is straighten this guy out a bit. And we're actually up at a pretty good elevation right now. We're at 7,000 just on our regular engines. But before this thing gets too far away, so what I'm going to do now is I'm going to fire up the rocket here, and then I'm going to pitch up really hard. So fire our rocket, and we'll back off the throttle a bit. We want to have just enough throttle that it holds the climb pitch, but not enough that we go stupid fast, because we're not trying to go, this thing's not really meant to go Mach. So now in theory, as long as we have enough fuel, what we'll do is we're going to climb up to that altitude. So we've entered into the zone now, and we have to get above 19,100. So we're just kind of waiting. You can hear the jet engines just cut out there. And now that we're at 19,000, we're going to take our crew report, and you can see we collected our crew report. So I'm going to kill the engines now. And for the most part, we just have to let this thing drift back down because we're way up into the really thin atmosphere here, so we're not going to have a lot of control or lift. So generally speaking, you just want to kind of keep your nose kind of near your velocity vector. We actually got high enough the sun came back up too. That's kind of fun. Can we get any science while we're up here? Get an observation bay. Get 2 science from Goo. Sure, keep it. Let's throw it over there. Can't get any pressure. And can't get a thermometer. So because it's nighttime and because I can't see anything and I have no markers at KSP, I decided to just go for a water ditch, and I think everything, yeah, it looks like all the parts made it. You can definitely land in water, you want to make sure you have a really slow speed and a really slow vertical drop. I actually had the vertical drop got a little away from me there, but she still survived, so that's cool. But so yeah, that's how you do one of those missions that you need to actually jump up to a certain altitude and take a reading like that. And we managed to snag another 24 science. We've got 88% of our vessel back. It's not horrible. And I think that will be the end of episode 2. Because that pretty much covers at least the starter basics of planes and how to do the first 2 types of missions, the below and the above altitudes. Next episode we'll probably spend some science and also probably build a rocket to go up to orbit. So we'll see you then.